Right, so area is pi times the radius squared. So we're doing pi. The radius is given straight up as 4.1. That's where we're looking at. So with this one, you've got your diameter of 15. We need the radius. Need to make sure we work that out first. And then that becomes the value we put into our area of a circle formula. So with this one, like I said, we know the radius it's given. Halving the area formula, either divide by 2 or writing it as a half, we've still got to square the radius regardless. 157.08, go to 2 decimal places, centimetres squared. So we've researched that the diameter of a 20-cent coin is 22.25 millimetres. The radius is 1.25, therefore millimetres. Divide that by 10 to change that to centimetres. It's nicer to work with centimetres. No, not interested in the thickness. So about 3.888 centimetres squared. Now, we also know that 1 metre squared, or we should know, is 100 centimetres by 100 centimetres, which is 10,000 centimetres squared. So we need to know how many of these go into that. We don't really want to change the area to metres squared of a 20-cent coin because it's really small. So we need to set up that division. How many of these goes into there? And so, yeah, 2,572. I meant to say estimate your answer first. Would you have estimated about 2,500? Probably not. Yeah. It's a bit deceiving. 1 metre squared is actually quite a big area. A radius of 3.5, diameter is 7. So we need the radius, remember, for area of a circle. And before we can work out what's required, we want the area of one circle. And so that's the 38.48. How do we finish this off now? What do we do? We want to work out the amount of cardboard left over. So once we take out all of these circles, there is 8 of them. What's left is what we require. So what's left? Take away those 8 circles. A little bit like an egg carton. Taking out those circles, we've got a rectangle. So if we find, what's one way to do this? Finding the area of the big rectangle and taking away the 8 circles. So we want 700 taking away 8 of those areas of those circles, and that leaves us with the area left over. You've got the area of your 2 circles, slightly smaller one, slightly larger one. Find the difference in their area, and it does say correct to 2 decimal places. So the bigger one, take the smaller one, that's it. So how many pieces in that if it's 60 degrees? Yeah, 360 over 60 is 6, so 6 pieces of pizza. So it's 1/6 of the area of a circle. This one at 45 degrees, how many pieces? Too many? Is it 8? No. 90? Yes, 8. So here we want the area of the circle divided by 8. And I guess the point is, well, which one gives you the biggest area? Because that's giving you the biggest amount of pizza, but then relate that back to the cost. So pi times 6 squared, and then we divide by 6 because it's 1/6 of a piece, of a pizza. One piece represents 1/6. So that's about 18.85 centimetres squared. And then the second one, the second piece of pizza, is dividing by 8, but the radius is 7 inches. So times by 7 squared. And then we divide by 8 because it's 1/8 of a pizza. And so which is the better buy? We need to compare what? Here. So if we work out the amount of pizza per dollar, so this is centimetres squared, and divide by $1.50, that gives us 12.57 thereabouts centimetres squared per dollar. And for the next one, we need to also work out what that cost is per dollar. So 19.24 centimetres squared, but this is a different cost, so we've got to divide by $1.70, not $1.50. 19.24 divided by 1.7 gives us 11.31 centimetres squared per dollar. And so which one is the better buy? Which one gives us more pizza for our dollar? First or second? Which one is it? Which one gives us more pizza per dollar? This one is 12.57 centimetres squared. That's 11.31. Which one's the bigger one? The first one, yeah. So that one there is the better buy. Better value for money. All right, let's try the next one. So because this is a semicircle, remember we have to halve the area of the circle. It says one of the goal semicircles. Yeah, so because it's one of them. But yeah, otherwise you're right. If it was just the goalie area, it would be the 2 semicircles. So I'm getting 37.71 to 2 decimal places. And it's metres, not centimetres. And then the size of the shaded is where wing attack can play. So wing attack can play across the 2/3, but not the goal circle. So the 2/3 but not the goal circle is, the 2/3 is represented by a rectangle. That rectangle. So I guess we do need the 15.25 and 2 of these, which is 20 and 2/6. I don't like how they've done that. If you're doing this on the calculator, it's 20 plus 2/6, which is 20 plus 1/3. It does round to 20.3, but it is 0.3 recurring. So 20 plus 1/3 is better to write.